Hi everyone, Marek here, and welcome to the demo of my zkApp, which I developed for the zkIgnite Cohort 0 program. And sorry if I look very tired, it's midnight here. I decided I have to record it because, the debugging could take forever, and at some point you have to stop. So, uh, we'll probably do it in parts because there is many features and some of them take very long time. But first, let me just say that I have deployed it to both GitHub pages and my website. But what I will actually show you will be the local because that's the one that loads snarky.js correctly. So before actually I start talking, let me just hit this load snarky.js button. Just to get started the steps, which take a long time, so that we can save the length of this video. All right, snarky.js loaded. Let's connect AURO wallet. I have my special notes here. You will see my password, but it's okay because it's just testnet. There's no real accounts here, so don't worry. It's fine. So there it is. This is my zkApp. snarky.js is loaded. AURO wallet is connected. Displays the current block number. And let's hit this compile circuit button because it will take at least 20 minutes. So I might stop at some point and wait for it to compile. So yeah, now we will have some time to talk about what is this zkApp actually about. So MAC stands for Mina Arbitrated Contracts, because it's actually not just a zkApp. This is a zkApp that makes zkApps. So you can actually use it to create contracts without coding, without knowing how to code. So I will explain how it works in a minute. But if you're interested to just read what I've written here, you can just visit mac.squarerootofxx.com, sqrtxx.com, which is my website. And you can read without loading snarky.js, so that should work without problems. Here, the circuit is compiling, so let me just say a few words about it. You have few features here. You can create new zkApp. You can interact with one. You can close it. You can import and export, and also you can just read the website. So this is this engine allows you to create multi-party zkApps, which allow you to interact with multiple people. So there's a way to import and export the circuit because the transactions are done off chain. Sorry, not the transactions, the interactions. So how about we just make a zkApp? So I click on new zkApp. There it is. So I can see the address which I have connected with my AURO wallet right now. This is the current blockchain length. Let's generate a private key and public key for the zkApp. So the color coding is in pink, it's the public information. In yellow are the blockchain lengths. And in blue, blurred, is the private key, the secret keys. So let me just copy it. As you can see, I already deployed quite many. It's going to be contract 12. This is the private key. Let me also copy the public key. Guys, I don't guarantee everything will work at this demo because I did it many times and it did not always work. So let's keep our fingers crossed. So yeah, I take this private key, put it here. So since we look at this form creates the zkApp. So let me just tell you how it works. Basically, the Mac engine allows you to create zkApps that act as escrow. So you can secure various operations and contracts between people using the zkApp. So what you have here are the participants, which take the public keys. I made quite a few accounts which are well funded. There's Rick, Morty, Jerry, and Summer. So let's take Rick. It's going to be the employer. Rick is going to hire Morty, and there will be Jerry, who is going to be the verifier party of this whole contract. So what's the subject? So Rick is hiring Morty to, let's say, maybe go do some laundry. So Morty will go do the laundry. So this value is going to be turned into a circuit string object. It will be stored in what I call the contract per image. The amounts. So Morty will be paid 0.14 mina for his service. But he also has to put 0.03 mina, say guarantee deposit. There is some sort of penalty. This is percentage. So how much of this deposit will Morty lose for not finishing his job on time? And there's also penalty for canceling. So Morty will have he will have a possibility to cancel early within certain time span expressed in blockchain lengths, but for penalty. So he will lose some of his deposit. Employer, who is Rick, also has to put some deposit. And they both pay to Summer or Jerry for the arbitration. And this is the share. By default is 50%. So let's just keep it this way. And Jerry, for doing his arbitration service, will earn 0.03 mina. But has to put deposit at stake 0.07. In general, the arbitration party has the least to lose by not interacting. So I suggest to put very high deposit here. It's non-acting penalty, which is supported in the smart contract, but it's not supported in the UI. So I will just skip it. And here there are the deadlines. So the warm-up is how much time you have to wait before you can actually deposit. And this is in blockchain length. So this is like 5 blocks. This is 10 blocks. So let's just put, I don't know, well, it will compile for a while. So let's just keep 5 blocks here. And the deposit time, how much time everyone has to deposit. Execution time, this is the time when Morty has to do the job. And failure declaration time is how long Jerry has to declare that Morty has failed. There's also a possibility to put some strings here, which are it's actually not mandatory, but you can put some extra information here that describes why you made certain choices. So we can write here that arbiter is unreliable, has to pay more, whatever, success, yay, failure, no, geez, cancel, whatever. I know it's not correct, but whatever. So it's still compiling. So if I click next, it will create a contract per image. There it is. We can deploy it or interact with this if we want. This is the summary of the contract. So here are the parties involved in the contract, just their main addresses. These are the outcomes. So there could be deposit, success, failure, cancel. When can it start? When, before. So these are the deadlines. So after and before in terms of blockchain lengths. And here are the different parties. So how much they have to deposit or how much they can withdraw. And this is the net total. So as you can see, it always sums up to the same value. Here is the description. So that's the actual contract. And here's some additional information for each of the outcomes. So we still wait for it to compile. So maybe in the meantime, I can show you a feature I designed called the MacPacks. So for any kind of multi-party interaction off chain, there is usually a problem of how to how to actually share the information. So personally, I'm not a fan of JSON objects. So shoot, I cannot. Okay, I will explain you. So actually, all the long polling tasks run on the snarky.js worker thread. And this is one of things that has to use this thread. So I made in the UI, I made this button blocked while it's compiling, just to not make user click here and wait for a very long time. So we just have to wait for it to compile before we can do anything. So yeah, so before I show you this feature, maybe I can just tell you one more thing. Actually, there is a problem with the AURO wallet. The AURO wallet, so this tool allows you to do the whole cycle of the app. So you can make the app, you can deploy it, and you can interact with this. But I had huge difficulties using AURO wallet for that. Basically, I would just get OCaml errors. Like, I don't know if it's the node that rejects those transactions signed with AURO, or is it the AURO that is not signing them correctly. But long story short, AURO wallet connects to this app, provides the address almost always, but it doesn't sign the transactions correctly. So I have an alternative. I have two modes of interacting with the Berkeley network. One of them is the AURO wallet, which is not very operational. But there's another one. There is also what I call the private key mode, which will I will remove it as soon as AURO gets fixed and works correctly with the deployment. But this allows you to actually already start to use it by just providing your private key. So if I use the private key mode and provide the private key of whatever, maybe Rick, and click here, now I use this identity. So if you switch to the private key mode, then circuit has compiled. Perfect. If you switch to the private key mode, you do not need to use AURO wallet. So since the circuit has compiled, the only thing we can do is deploy, because it only shows you the actions that are available within this time frame. So I will show you the MacPack feature, which I'm very proud of. I really like it. So actually, once let's say I'm Rick and I define this smart contract, I make the zkApp, and I want to share it with Morty and Jerry, because they also need to interact with this, right? So for this, I designed what I call the MacPacks. So I can export it. Oh shit, I cannot click here. Oh no. That's okay. I will show it to you later. So I think this is a bug. Whatever, it's okay. So let's try to deploy. I don't guarantee it will work, but let's see. Okay. Yes, so this is the transaction. It's still pending. So let me just summarize what we did until now. We have created a zkApp that represents a real interaction contract. And so we defined it, we compiled it, and we deployed it without using any coding, just by clicking on the UI. So speaking of UI, let me tell you what we can see here. So it will always show you the link with the last transaction, and here are the actions you can execute. So deploy deploys the contract. Initialize takes your contract per image, which is what we defined earlier, computes a Poseidon hash of it, and initializes the contract. So on chain, we do not store any public information. We only store the hash, and this is what secures the contract. So it ensures that only people who own the pre-image could potentially interact with this. So this is what happens if I click on initialize. But now if I do it, it will not work because this transaction is still pending. So after it's on the block, we can try to initialize it. For now, it's a bit too early. But let me just tell you that these actions, these are all the actions you can do. So you can deploy, initialize, you can deposit, withdraw. Here, the last three actions are for the arbitration. So like the jury can judge if Morty has correctly did the job or judge that he failed. There's also cancel. Cancel once the contract starts, so the deposit opens, but before it finishes, it's possible to cancel for free. So this button would just highlight for everyone. And if you do it, the smart contract will allow you to withdraw whatever you deposited free of charge without any penalty. But after the deposit is closed, the only way to cancel is within this time frame, and the only party that can do it is the contractor. So this gives contractor an option to to just cancel. Like contractor has right to cancel, but has to pay for it a little bit for not being decisive or not planning properly or whatever. So the contract is in the warm-up stage, so the deposit is not yet open. So for that reason, it only allows us to deploy and initialize. And normally you would have to wait. So this is the block 8453. It will open on 8456. So in 12 minutes, I suppose. I'm not sure if I will wait this long. Let's see. Meanwhile, maybe this transaction will get verified. Oh yeah, it is. 0 block confirmation. Let's wait for at least one block before we initialize. Guys, I don't guarantee it will work because I think this project is a bit too ambitious for the kind of resources I predicted for it time-wise, and in general it's working. Like the contract is passing all the tests. I interacted with this using the CLI, and it's in general it's working, but sometimes it doesn't, and you never know. So I'm a bit afraid of clicking here because I don't want to spoil the demo, but eventually I will do it, I promise. So let's just refresh here. Let's wait for at least one block confirmation here. So Morty will go do the laundry. So maybe meanwhile, while we wait for the block confirmations, let me just share a little bit of vision of this project. So I came up with this in Colombia when I came to meet you guys from of One Labs, and I had this idea on the plane that I would like there to be a zkApp that would allow everyone to create something on the network. I don't really want I don't really want zkApps or any apps or any smart contracts to be something only for developers, um, because there's just so creative people who have so many ideas, and sometimes those ideas do not really need much to come true. And I think a tool like this would make it possible for them to, create create various ways of using the blockchain. And I imagine that in the future there could be marketplaces where people would share those contracts and secure their interactions using those contracts, like online purchases. Like, you could totally make payment be zero and just pay with US dollars or whatever, and just use Mina coins as deposit just to secure the interaction. There's so many possibilities, and it will all make sense much more once I show you the feature called MacPacks here. But let's run this initialize transaction first. Like I will, guys, I will immediately tell you I will not do the entire flow because it would take a lot of time. Just look at these. Just look at these. Like, there are three parties, so there's many actions. Each of them needs some block confirmations. Sometimes they don't work, hard to tell why, and they have to be within these time frames. So it would take hours to do it. So I just want to show you that it can deploy and it can run a transaction, and that's it. So do we have any confirmations here? Still 0. 1 minute ago. Yeah, the block is every 4 minutes or something in average. Too bad this doesn't work. I mean, it is working. It's just for some reason I didn't do this correctly. Like, usually I don't click compile that soon. So anyway. Oh no, it's refreshing. Damn it. Yeah, see guys, this is what happens when you work on the dev mode. So we lost everything. We had our compiled contract, but it's okay. I promise I didn't do it on purpose. uh, but we made one transaction, so that's something. Okay, so just for cheer up, I will show you a different feature. Let's just load snarky.js again. And let's connect our wallet. Yay. This time I do not click compile circuit. This time I just create a new zkApp. So, private key, let's generate it. Participants, I will just steal from some previous values. Let's say Morty will buy some eggs for the usual compensation. I usually put the same values. I already have my favorite values for this contract. Okay, these let's just leave empty. Next. So we have created a new zkApp. Let's export it. Oh no, the finalize step is not working. Again. Okay, you know what, guys? I will cheat a little bit and make it clickable. Somehow. I think there should be a way. Or not. Let's not make it disabled. Let's make it regular. Oh, but there's no action. Yes, there is. Okay, great. So I had to cheat a little bit, but thanks to this, I can show you the feature. So you know what this is? This is the zkApp we just created. I call it a MacPack. So what happens is I take all the fields from the circuit value that represents the contract. I serialize it into a sequence of binary values, and I mean everything: the strings, the descriptions, the values, everything. And there's even a version so that you can mix different serializers in the future. And then I export it to base 58. I encode it using base 58. I set the word length, so this is one word, which is 13 characters, and that's it. That's the MacPack. The MacPack is your contract. So people could, like, all you have to do is just have this MacPack, right? And just save it for the future. So after you define it, you can send it to someone. You can send it using, well, it's a bit too long for Twitter, but you could send it on Facebook or Telegram or whatever you like to use and share your contract with other participants. So all they have to do is click on import, and then they can use the same contract. So I will just close it and I will import. Paste your MacPack here. There it is. Import. Okay. And let's click interact. There it is. This is our contract. More, you will buy some eggs. Isn't that amazing? So the whole idea of the MacPack is based on the Slate Pack, which is a transaction building message used in green cryptocurrency. And I really enjoy Slate Packs. I like sending them, receiving them. And I just thought it's a shame that other people don't use something like this. I mean, other coins usually don't have interactive transactions, but it's still a great way to share data between participants. And I just really wanted to use it, and I did. And I'm really happy about it. So imagine different clients like websites or CLI or apps. You can put it in the QR code, like you can put it anywhere you like and just share. So imagine on eBay or some other marketplace, someone says, okay, yeah, I will accept your offer, but let's secure it using the Mina blockchain. So he creates the MacPack that puts some sort of deposit and lets someone verify if the transaction was really correct, right? And I also imagine that we could, so this is very basic. There's just one person that verifies, but it's not enough. I would like there to be like N verifiers and they would vote. So, for instance, you get M out of N, then it's approved. And it would also decide on their compensation if they will be compensated or not. So, or there could be veto, like by default, it's success unless one of them disagrees or something like this. You know, something like jury kind of thing. There's many ideas we could implement potentially in the future with this app. So, but in the current stage, it already takes crazy long to compile. So it's really hard to think how to make the circuit larger without making it harder to use. Well, for sure, if we could serialize the compiled circuit, that would already improve the user experience. So the user doesn't have to wait such a long time to participate. Anyway, guys, I'm not going to compile it again. It takes too long. So I'm sorry, we only did one transaction, but I hope it's enough. Like, it's a very complicated project. Anyway, thank you so much for watching. Thank you for your time. I hope you liked it. I hope you wish to support this project. You can send me a message if you have some ideas. I will be happy to discuss. Make sure you visit my website, this one, squarerootofxx.com. And that's Mac. That's everything. Thank you so much. Goodbye.